Dear students, already in the last class we discussed basic inverse trigonometric functions. We discussed the inverse of sine function and also the inverse of cosine function. Okay, that is, we say sine inverse x is equal to y provided x is equal to sine. By definition, sine inverse x is equal to y will imply that x is equal to sine y, where y lies in the interval minus pi by 2 to pi by 2 and x lies in the interval, my closed interval, minus 1 to 1. Similarly, cos inverse of y is equal to x implies, cos inverse of x is equal to y implies that x is equal to cos y if y belongs to closed interval 0 to pi and x lies in the interval minus 1 to 1. So from this we have seen that the domain of sine inverse x is minus pi by 2 to pi by 2 and the range of sine inverse x is closed interval minus 1 to 1. Similarly, the domain of cos inverse x is the closed interval 0 to pi and the range of cos inverse x is the closed interval minus 1 to 1. We can see this graphically also. That is, already in the last chapter we have discussed, that is, if y is equal to f of x is any invertible function, then f inverse of x, the inverse of f, the graph of f inverse of x is the mirror image of the graph of f of x. In other words, if a comma b is a point on the curve y is equal to f of x, then b comma a is a point on the curve f inverse of x. Okay, so on this, let us see the graph of sin x and sin inverse x, and similarly the graph of cos x and cos inverse x. Okay. Students, as we know, this is the graph of sin x, 0, pi, 2 pi, etc. Here this is pi by 2, minus pi by 2, pi, minus pi, etc. Okay. Now, earlier we discussed that the inverse exists for this sine function if and only if we restrict the domain to minus pi by 2 to pi by 2, minus pi by 2 to pi by 2. Okay. So now let us look at the graph of this function only between minus pi by 2 and plus pi by 2. Now, the graph of sine inverse x, I would like to draw the graph of sine inverse x, which is the mirror image of the curve y is equal to sine x with respect to the line y is equal to x. In other words, here to draw the graph of sine inverse x, you interchange the x and the y coordinates, or interchange x and y axis. So the graph of sine inverse x will look in this way. This is 1, this is minus 1. Graph of sine inverse x lies between minus 1 and 1 only, because the domain of sine inverse x is closed interval minus 1 to 1. And this is 0, this is pi by 2, this is minus pi by 2, etc. This is the graph. Now, look at only the portion of the curve between minus pi by 2 and plus pi by 2. This is what we observe. Now compare these two graphs, the graph of sin x and the graph of sine inverse x. You will see that this graph is the mirror image of this graph with respect to the line y is equal to x. See, I will draw these two graphs together. That is, see, this is the graph of sin x. On this only, I will draw the graph of sin inverse x. Then this is what you get. Okay. Now here is the line y is equal to x. This is the line y is equal to x. This is the graph of sin x, and this is the graph of sin inverse x. Observe that the graph of sin inverse x is the mirror image of the graph of sin x with respect to the line y is equal to x. Okay. In the same way, we can discuss the graph of cos x and cos inverse x. The graph of cos x, as we know, the graph of cos x. This is the graph of cos x. This is 0, pi by 2, pi, 3 pi by 2, 2 pi. And on the other side, minus pi by 2, minus pi, minus 3 pi by 2, and so on. This is the graph of cos x. Now, if you try to draw the graph of cos inverse x, that will be the mirror image of this graph with respect to the line y is equal to x. Okay, let me draw it here. This is 0, 1 and minus 1. Okay. So then this is minus pi by 2, minus pi. Here this is pi by 2, pi. Okay. So now you compare these two graphs. This is the graph of cos x and this is the graph of cos inverse x. The graph of cos inverse x is the mirror image of the graph of cos x with respect to the line y is equal to x. Okay, or you just observe here, if we rotate it, if you interchange x and y axis, this is what you get. This is the graph what we obtained by interchanging x and y axis in this graph. Okay, let us move forward. Now, let us discuss the inverse of tan function, or in other words, tan inverse of x. Okay. So, again here also, tan x, in general, if we are defining f from R to R, defined by f of x equal to tan x, then tan x is not a bijective function. This is not a one-one function. For example, f of 0 is equal to tan 0, which is equal to 0. F of 2 pi, that's equal to tan 2 pi, which is also equal to 0. So, two different elements of the domain are having the same image in the codomain. Therefore, tan x is not a one-one function in this domain. Okay. So, if we restrict the domain and the range of tan x is the set of all real numbers. In other words, the open interval minus infinity to infinity. So the range of tan x is the set of all real numbers. Range is equal to codomain. So it is an onto function. Okay. So there is no need to restrict the codomain here. Only we have to put some restriction on the domain so as to make it as a bijective function. Okay. So now instead of the domain as R, I will choose the open interval minus pi by 2 to pi by 2. I will choose this interval as the domain. F is defined from this interval to R. Open interval minus pi by 2 to pi by 2 is the domain and R is the codomain. So here if I define tan x, f of x will tan x defined in this interval, then it will be a bijective function. So if the domain is minus pi by 2 to pi by 2 and the codomain is R, then for the function tan x, we can define tan inverse of x. Let us see how. So, we say y is equal to tan inverse x if x is equal to tan y, where y should lie in the open interval minus pi by 2 to pi by 2. X can be any real number. Okay. So, y is equal to tan inverse x will imply that x is equal to tan y, where y belongs to open interval minus pi by 2 to pi by 2 and x belongs to R. X can be any real number. Now, let us look at some examples. Say, I will start with the tan inverse of 1. Tan inverse of 1, this is equal to pi by 4, since tan pi by 4 is equal to 1. Then tan inverse of 1 by root 3. Tan inverse of 1 by root 3 is equal to pi by 6, because tan pi by 6 is equal to 1 by root 3. Then what about tan inverse of minus 1? Tan inverse of minus 1. Let us say we don't know that value. What do? We will take tan inverse of minus 1. Let it be equal to some number. Let me say y. Tan inverse of minus 1 is equal to y. Then according to the definition, we can write tan y is equal to minus 1. Now I have to choose some value for y such that tan y becomes minus 1. While doing so, I have to ensure that this y lies in the interval minus pi by 2 to pi by 2. Tan y is equal to minus 1. So I can write tan of this y I keep as this minus 1. I will write it as tan of minus pi by 4. As you know, tan of minus pi by 4, which is equal to minus tan pi by 4, which means tan of minus theta is equal to minus tan theta. That will give you minus 1. Okay. So this suggests that y is equal to minus pi by 4. Now you may be thinking, sir, why can't we write minus 1 as tan 3 pi by 4? Tan 3 pi by 4 is also equal to minus 1. Then why not y is equal to 3 pi by 4? See, even though it is true that tan 3 pi by 4 is equal to minus 1, but this y should be in the interval minus pi by 2 to pi by 2. That 3 pi by 4 does not lie in this interval. Hence, tan inverse of minus 1 must be equal to minus pi by 4 only and not 3 pi by 4. Okay. Now, let us look at the graph of tan inverse x. For that, first I will draw the graph of tan x, and after that I will show you the graph of tan inverse of x. Okay. See, tan x, as we know, tan x at 0 it is 0. At pi by 2 it is not defined. This is pi by 2, this is minus pi by 2. Okay. Then this is pi 3 pi by 2. Pi and so on. Okay. So now here, to define tan inverse x, we have restricted the domain to open interval minus pi by 2 to pi by 2. So within this interval. Now I want to draw the graph of tan inverse x. So the easiest method that is available is interchange x and y axis. So if we interchange x and y axis, and then this is what we get. The graph will look like this. This is pi by 2 and this is minus pi by 2. Okay. So x can be any real number, but tan inverse x will always lie in between minus pi by 2 to pi by 2. The open interval minus pi by 2 to pi by 2. This is the mirror image of the portion of this curve. See, I will rub this because we are, as far as inverse is considered, we are looking at only the open interval minus pi by 2 to pi by 2. Okay. So look at this graph and look at this graph. This is the image of this graph with respect to the line y is equal to x. This is the graph of tan inverse x and this is the graph of tan x. Okay. Now let us discuss cosecant inverse x. Cosecant inverse x. Okay. So suppose cosecant x is equal to y, then we say x is equal to cosecant inverse y. Cosecant x is equal to y, then x is equal to cosecant inverse y, provided y lies in the interval minus infinity to minus 1 union 1 to infinity and x lies in the interval minus pi by 2 to pi by 2 except 0. Okay, so in other words, x should lie in the interval minus pi by 2 to 0 union 0 to pi by 2, which means minus pi by 2 to pi by 2 excluding 0. Okay, so if x lies in this interval and y lies in this interval, then we write cosecant x is equal to y. This will imply that x is equal to cosecant inverse y. Then if you look at secant x, say suppose secant y is equal to x, this will imply that y is equal to secant inverse x if x belongs to minus infinity to minus 1 union 1 to infinity and y belongs to closed interval 0 to pi except pi by 2. So for secant inverse x, the domain is this interval minus infinity to minus 1 union 1 to infinity, or you can also write this as set of all reals except open interval minus 1 to 1. From the set of all real numbers, if we exclude this open interval minus 1 to 1, that is the domain of secant inverse x, and the range is 0 to pi except pi by 2. Close interval 0 to pi minus pi by 2. That means from this set, this element pi by 2, that value is excluded. Okay, so then one more function we have, which is cot inverse x. Okay, suppose if you have cot y is equal to x, then we write y is equal to cot inverse x if x belongs to, or x can be any real number, and y belongs to open interval 0 to pi, which means the domain of cot inverse x is the set of all real numbers and the range is open interval 0 to pi. So for these three also, that is secant inverse x, cosecant inverse x and cot inverse x, similarly like what we did for sin inverse, cos inverse and tan inverse, we can draw the graph and identify. You can refer the textbook also for those three graphs. Okay, so now I will make a list of all the domain and the range of these inverse trigonometric functions. I'll write a table. So the first column I'll mention the function, which function I'm writing. In the second column I will write the domain, and then in the third column I'll write the range. Okay. So sin inverse x. The domain of sin inverse x is closed interval minus 1 to 1, and the range is closed interval minus pi by 2 to pi by 2. And then domain of cos inverse x. Cos inverse x, its domain is same, -1 to 1, and the range is 0 to pi. Tan inverse x. The domain of tan inverse x is set of all real numbers, and the range is open interval -pi by 2 to pi by 2. Then for secant inverse x, the domain is set of all reals except the open interval -1 to 1, and the range is closed interval 0 to pi except pi by 2. Then for cosecant inverse x, the domain is set of all reals except -1 to 1, and the range is closed interval -pi by 2 to pi by 2 except 0. Okay. Then for cot inverse x, the domain is set of all reals and the range is open interval 0 to pi. So students, make a note of this. This table is very essential to solve the problems which comes in this chapter. Okay, so again I will repeat all this. For sin inverse x, the domain is closed interval -1 to 1, and the range is closed interval -pi by 2 to pi by 2. For cos inverse x, the domain is closed interval -1 to 1, and the range is 0 to pi, closed interval 0 to pi. For tan inverse x, domain is the set of all real numbers, and the range is open interval -pi by 2 to pi by 2. For secant inverse x, the domain is set of all reals except open interval -1 to 1, and the range is closed interval 0 to pi except pi by 2. For cosecant inverse x, the domain is set of all reals except open interval -1 to 1, and the range is closed interval -pi by 2 to pi by 2 except 0. Then for cot inverse x, the domain is the set of all reals and the range is open interval 0 to pi. Okay. Thank you.